Finite wave train. One of the important applications of Fourier transform is the resolution of finite pulse into sinusoidal waves. Consider a wave train and from this wave train, imagine that an infinite wave train sin omega 0 t is clipped by Kerr cell or a saturable dicell shutter, so that we have f of t is equal to sin omega t when time is less than n pi by omega 0, and f of t is 0 if time is greater than n pi by omega 0. So this whole wave train a small part cut using a Kerr cell. What is Kerr cell? A Kerr cell shutter is a type of photographic shutter used for very fast shutter speeds down to nanoseconds. And the Kerr cell makes use of Kerr effect, in which nitrobenzene becomes birefulgent under the influence of electric field. This allows it to be used as shutter that can be opened for a very brief amount of time, around 10 nanoseconds. So a brief amount of time we shutter open wave train some part cut clip and we clip a wave small part sin omega t for our time less than n pi by omega 0. Time 5 pi by omega 0 1, 2, 3, 4, 5 wave train. Okay, so this wave train corresponds to n cycles of our original wave train. Now if you consider f of t is a sine function, f of t is odd. So we will use Fourier sine transform. If the function odd sine transform use ചെയ്യും. And then we can write down the Fourier transform GSW as root 2 by pi 0 to n pi by omega 0. Then this is f of t, function sin omega t dt. Okay. So this is our Fourier sine transform equation. Gs omega is equal to root 2 by pi 0 to infinity fst into sin omega t dt. Now instead of infinity, we n pi by omega 0 substitute. And what is fst? Our fst is now sin omega 0 t, f of t. Function is sin omega 0 t. Okay, and t is n pi by omega 0. The random substitute. Okay, so this can be written as this is equal to root 2 by pi integral from 0 to n pi by omega 0 sin omega 0 t into sin omega t dt. Now in the integral we have in the form of sin A sin B function. So we know that sin A sin B is equivalent to half cos A minus B, half cos A minus B minus cos A plus B, cos A minus B minus cos A plus B. So this can be written as root 2 by pi integral 0 to n pi by omega 0 half cos A minus B will be cos omega 0 minus omega t in minus cos omega 0 plus omega dt. And if you integrate this function, then integral of cos x will be equal to sin x. So this integral will be equivalent to root 2 by pi, then sin omega 0 minus omega into t by omega 0 minus omega. Now this 2 is written here, and you will have limit from 0 to n pi by omega 0 plus sine omega 0 plus omega t divided by 2 into omega 0 plus omega, again limit from 0 to n pi by omega 0. So first you have to apply the upper limit, then the lower limit, and if you apply the limits, this will be equal to root 2 by pi sine omega 0 minus omega into n pi by omega 0 divided by 2 into omega 0 minus omega minus sine omega 0 plus omega into n pi by omega 0 divided by 2 into omega 0 plus omega. So this will be your GSW. So our result is GSW is equal to, integrating we find that GSW is equal to root 2 by pi sine omega 0 minus omega n pi by omega 0 by 2 omega 0 minus omega minus of sine omega 0 plus omega n pi by omega 0 by 2 omega 0 plus omega. Now it is of considerable interest to see how this G of omega, Gs of omega depends on frequency. For large omega 0 and omega of the order of omega 0, only the first term will be of any importance because of the denominator. See, what denominator omega 0 plus omega. So for large omega 0 and omega 0 of the order of omega 0, this denominator large quantity out. So this term vanishes. So this first term is of considerable interest. Okay. Now if you plot this first term, then this is the amplitude curve of single slit diffraction pattern. So if you plot the first term, you will get the diffraction curve like the curve look like the diffraction pattern of a single slit curve. Now let us consider the uncertainty principle in quantum mechanics. If we are dealing with electromagnetic waves, then we know that the energy of the electromagnetic wave, energy E, is equal to h nu, and nu will be omega, and we have omega is equal to 2 pi nu. So E will be equal to h into h omega by 2 pi. So delta E will be equal to h delta omega by 2 pi, where delta E represents the uncertainty in the energy of our pulse. And there is an uncertainty in the time also. For a wave of n cycle, for our wave of n cycle requires 2n pi by omega 0 seconds to pass. So the uncertainty in time delta t will be equal to 2n pi by omega 0. Now if you take the product of delta E into delta t, then you will get h delta omega by 2 pi into 2 pi n by omega 0. So you can cancel these 2 pi and 2 pi, and now delta omega is omega 0 by n. So now you can cancel this omega 0 with this omega 0 and n with this n. So delta E into delta t will be equal to h. And according to Heisenberg uncertainty principle, delta E into delta t is greater than or equal to h by 4 pi, and this is clearly satisfied in our example. Delta E into delta E is of the order of h.
Let us solve this problem.
The function f of x is equal to 1 if mod x is less than 1, and the function f of x is 0 if mod x is greater than 1. So when x is greater than 1, the function is 0. Now suppose this is x is equal to 1. This is the point x is, if this is x is equal to 1 point, then f of x is equal to 1 if mod x is less than 1. That means at this point f of x is 1, and at x equal to 1, after this point the function is 0. So if you plot the curve, then the curve will be like this. So this is a symmetric finite step function. Now we are required to find out the Fourier cosine transform of f of x, that is gc of omega, and then taking the inverse cosine transform, show that f of x is 2 by pi 0 to infinity sine omega cos omega x by omega d omega. So first cosine transform കാണണം, then inverse cosine transform is equal to this much to prove ചെയ്യണം. Then from this integral we have to show that integral from 0 to infinity sine omega cos omega by omega d omega is equal to 0 if mod x is greater than 1, and if x is equal to 1, that is equal to pi by 4, and if x is less than 1, this integral is equal to pi by 2. Okay, so let me solve this problem. So first find out the Fourier cosine transform of f of x. Now we have the Fourier cosine transform gc of omega is equivalent to integral root 2 by pi integral 0 to 1 cos omega t dt, because our function is equal to 1. Function 1 also. Now നമുക്ക് evaluate ചെയ്യാം. So if you evaluate this integral, the integral will be equal to, first we have root 2 by pi sine omega t by omega, and limit will be from 0 to 1, and if we apply the limits, then you will get root 2 by pi sine omega by omega, and this is the first question. First we have to prove this. Find the Fourier cosine transform of f of x. Okay. Now next we have to take the inverse cosine transform. Inverse cosine transform. So the inverse cosine transform will be fc of x is equal to root 2 by pi integral 0 to infinity gc of omega into cos omega x d omega, and here we have to substitute this gc of omega, so that will be equal to root 2 by pi integral 0 to infinity. Now what is gc of omega? This will be root 2 by pi sine omega by omega. So again you have root 2 by pi, then sine omega by omega, then cos omega x d omega. So this will be equal to now 2 by pi. Root 2 by pi into root 2 by pi will be 2 by pi integral 0 to infinity sine omega cos omega x by omega d omega, and this is our second question. This is taking the inverse cosine transform, show that f of x is equal to 2 by pi 0 to infinity sine omega cos omega x by omega d omega. Okay, so that part we have done. Now part C, we have to prove that integral 0 to infinity sine omega cos omega by omega d omega. So നമ്മൾ ഈ പാർട്ട് മാത്രം എഴുതി കഴിഞ്ഞാൽ this 2 by pi, here we have fc of x. So what is this thing എന്നുള്ളതാണ് ഞാൻ എഴുതാൻ പോകുന്നത്. Integral from 0 to infinity, integral from 0 to infinity sine omega cos omega x by omega d omega, that will be equivalent to this 2 pi by 2 ഇങ്ങോട്ട് പോകും, that will be equal to pi by 2 fc of x, or that is equal to pi by 2 f of x. Okay, now first part, if mod x is less than 1, then what is our f of x? F of x will be equal to 1 from our definition. So if f of x is equal to 1, what will be integral? This integral will be equal to pi by 2. Okay. Now if mod x is greater than 1, then f of x is equal to 0. So then integral will be equal to 0. Now next last part, if mod x is equal to 1, if mod x is equal to 1, what will be the integral? Integral will be equal to this integral will be equal to 0 to infinity sine omega x1 ആണ്. So sine omega cos omega by omega d omega x is equal to 1 എന്ന് substitute ചെയ്തു. Okay. Now we have sine 2a is equal to, we have an equation sine 2a is equal to 2 sine a cos a. So this sine omega cos omega can be written as this can be written as sine 2 omega by 2. Then here you have omega, then d omega, and now we have to integrate this function. So if you integrate this function, suppose I am giving u is equal to 2 omega, then du will be equal to 2 d omega. So d omega will be equal to du by 2. So if we substitute it back here, then this will be equal to half into integral 0 to infinity sine u, instead of 2 omega u എന്ന് substitute ചെയ്തു, sine u divided by u into du. So if you integrate this thing, you will get sine integrate ചെയ്ത് pi by 2 എന്ന് കിട്ടും. So this integral will be equal to pi by 2. So this is standard integral from 0 to infinity sine x by x dx is equal to pi by 2. So if I substitute pi by 2 here, then pi by 2 into 1 by 2, that will be equal to pi by 4. So if mod x is equal to 1, then integral is equal to pi by 4, and that is the third of this question C part. If mod x 1 ആണെങ്കിൽ pi by 4, if mod x is greater than 1, integral is 0, and if mod x is less than 1, integral is equal to pi by 2. Fourier transform of the derivative. Using the exponential form, the Fourier transform of f of x is equal to g of omega is equal to 1 by root 2 pi minus infinity to infinity f of x e raised to I omega x dx. Now if you find out the Fourier transform of the derivative of function f of x, then derivative of the function will be df by dx. Then the Fourier transform of the derivative will be equal to g1 of omega is equal to 1 by root 2 pi minus infinity to infinity df by dx into e raised to I omega x dx. So Fourier transform of the function f of x ഇതാണെങ്കിൽ നമ്മൾ Fourier transform of df by dx കാണുമ്പോൾ നമ്മൾ f of x ന് പകരം df by dx സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. എന്നാൽ നമുക്ക് ഈ ടേമിനെ ഇന്റഗ്രേഷൻ ബൈ പാർട്സ് ചെയ്യാം. So I am taking this as the first function, integration by part with this is the first function, and df by dx is taken as the second function. So the integration by parts will be the first function into e raised to I omega x into then 1 by root 2 pi first function into integral of second function. So df by dx in the integral നമുക്ക് f of x കിട്ടും. Now limit minus infinity to plus infinity minus integral of derivative of first function. So e raised to I omega x in the derivative കണ്ടാൽ നമുക്ക് I omega into e raised to I omega x വരും. Derivative of first function into integral of second function. Integral of second function again f of x dx. Limit minus infinity to infinity കൊടുത്തു. 1 by root 2 pi ആണ് ആദ്യം കാണുന്നത്. Okay. Now if f of x vanishes, the function vanishes at x equal to plus infinity and minus infinity. F of x plus infinity minus infinity vanish cheyaണെന്നുണ്ടെങ്കിൽ this term vanish ചെയ്യും. So g1 of omega will be equal to just this term വരും. Now what is this quantity? 1 by root 2 pi minus infinity to infinity f of x I omega of x dx is equal to g of omega. So our result is g1 of omega is equal to minus I omega into g of omega. Okay. So that is the transform of derivative is minus I omega times the transform of original function. Generalize this expression for nth derivative, then gn of omega is equal to minus I omega raised to n g of omega. So ഇവിടെ നമ്മൾ g1 റെപ്രസെന്റ് ചെയ്തത് ഇവിടെ നമ്മൾ df by dx ന്റെ Fourier transform ആണ് കണ്ടത് ഫസ്റ്റ് ഡെറിവേറ്റീവിന്റെ. Now nth ഡെറിവേറ്റീവിന്റെ Fourier transform കണ്ടു കഴിഞ്ഞാൽ that will be equal to minus I omega raised to n g of omega, provided that all integrated part vanishes as x goes to plus or minus infinity. And the operation now, what is ഇങ്ങനെ നമ്മൾ ചെയ്യുമ്പോൾ ഗുണം എന്താണ്? What is the advantage? The operation of differentiation has been replaced by a multiplication in omega space. An infinitely long string is vibrating freely. Then the amplitude y of the small vibration satisfies the wave equation dou square y by dou x square is equal to 1 by v square dou square y by dou t square. And we shall assume an initial condition. The y of x0 is equal to f of x, where f is localized and that is approaches 0 at large x. So this is the initial condition. Now applying Fourier transform, let us find the solution of this equation. So our equation is, the wave equation is dou square y by dou x square is equal to 1 by v square dou square y by dou t square. Now let us apply Fourier transform in x. So that means I have to integrate from minus infinity to infinity dou square y by dou x square. Now y is y of xt. Now multiply by e raised to I alpha x, then dx. So that will be equal to same operation നമ്മൾ RHS ൽ ചെയ്യുക, minus infinity to infinity dou square y of xt by dou t square, then e raised to alpha x dx കൊണ്ട് multiply ചെയ്യണം, integration ചെയ്യണം. Okay. Now this is equivalent to, we have the Fourier transform of the derivative. Using that equation, this will be equal to minus I alpha whole square integral from minus infinity to infinity y of xt e raised to I alpha x dx equal to 1 by v square dou square by dou t square minus infinity to infinity y of xt e raised to I alpha x dx. Now if I give y of alpha t is equivalent to 1 by root 2 pi integral from minus infinity to infinity y of xt e raised to I alpha x dx. If this is y of alpha t, then this term can be rewritten as minus I alpha whole square into, now y of xt e raised to I alpha x dx എന്ന് പറയാൻ നമുക്ക് y of alpha t എന്ന് എഴുതാം. So this is y of alpha t, that is equal to 1 by v square then dou square by dou t square. Now what is this quantity? Again this quantity is equal to y of alpha t. Now 1 by root 2 pi രണ്ട് സൈഡിലും cancel ചെയ്യും. Okay, so this implies that minus 1 square then I square minus 1 വരും, minus 1 square 1 ആവും, so minus 1 വരും. So minus alpha square y of alpha t ഞാൻ ഇവിടെ ചുരുക്കിയിട്ട് y എന്ന് മാത്രം എഴുതാനാണ്. minus alpha square y is equal to 1 by v square dou square y by dou t square. Okay. So now we equation this equation partial differentiation with respect to t മാത്രാണുള്ളത്. So എനിക്ക് equation full differential equation ആയിട്ട് മാറ്റി എഴുതാം. That is, we can write down this equation as d square y by dt square plus alpha square v square y is equal to 0. So our partial differential equation is converted into a ordinary ODE, ordinary differential equation ODE. And this equation is actually the linear oscillator equation. And this is an achievement, that is transformation from PDE to ODE and is an achievement. Now when time t is equal to 0, we have the solution y of x0 and that is equal to f of x. This is our initial condition. So our above equation, though this y of alpha t is equal to this equation, reduces to y of alpha times 0. So y of alpha 0 is equal to 1 by root 2 pi minus infinity to infinity. Now y of x0 will be times 0 y of x0 f of x out. F of x e raised to I alpha x dx, and this will be equal to f of alpha. So the general solution of this equation, or this equation will be equation in exponential form can be written as y of alpha t is equal to f of alpha into e raised to plus or minus iv alpha t. This is the general solution of this equation. Now using inversion formula, you can write down y of xt is equivalent to 1 by root 2 pi integral from minus infinity to infinity y of alpha t e raised to minus alpha x dx, or d alpha in terms of alpha, d alpha. So this will be equal to, now what is y of alpha t? Y of alpha t is equal to f of alpha into e raised to plus or minus iv alpha t. So if I substitute for y of alpha t, then this will be equal to 1 by root 2 pi minus infinity to infinity f of alpha e raised to plus or minus iv alpha t e raised to minus alpha x d alpha. So y of xt is equal to, so actually this is y of xt. So y of xt is equivalent to 1 by root 2 pi minus infinity to infinity f of alpha e raised to minus alpha into x plus or minus vt d alpha. Now f of x is the Fourier inverse transform of f of alpha. F of x is the Fourier inverse transform of f of alpha. So y of xt is equal to f of x plus or minus vt, minus or plus vt, corresponding to wave advancing in the plus direction and the minus direction respectively. Let us consider the partial differential equation of heat flow. Dou psi by dou t is equivalent to a square dou square psi by dou x square. Here psi of xt is the temperature in space as a function of time. Psi of xt is the temperature in space as a function of time. Okay, Let us take the Fourier transform. So integral from minus infinity to infinity dou psi by dou t e raised to I omega x dx will be equal to a square into integral from minus infinity to infinity dou square psi by dou x square e raised to I omega x dx. Okay. Now here I can take dou by dou t outside, dou by dou t integral from minus infinity to infinity psi into e raised to I omega x dx is equal to a square. Now here നമുക്കിവിടെ derivative of Fourier transform apply ചെയ്യാം. Dou square psi by dou x square into some, that is derivative of this function into e raised to I omega x dx ആണ്. സോ അവിടെ നമുക്ക് എന്ത് വരും, മൈനസ് I omega square whole square then minus infinity into psi of xt. So just psi എന്ന് എഴുതാം, e raised to I omega x dx. ഇവിടെ നമ്മൾ റെപ്രസെന്റ് ചെയ്ത ഈ psi, actually this psi is equal to psi of xt. Okay. Now if I represent psi of omega t as this is equivalent to 1 by root 2 pi integral from minus infinity to infinity psi of xt e raised to I omega x dx. അതായത് this is psi of xt. ഞാൻ ഈ ഇന്റഗ്രലിനെ, otherwise this integral, ഈ ഇന്റഗ്രലിനെയാണ് ഞാനിവിടെ psi of omega t എന്ന ടേം കൊണ്ട് റെപ്രസെന്റ് ചെയ്യുന്നത്. And if I represent like that, then this will be equal to dou by dou t of psi omega t is equal to minus a square എന്ന് വരും. ഇവിടെ മൈനസ് വണ്ണിന്റെ സ്ക്വയർ 1 വരും, then I സ്ക്വയറിന്റെ മൈനസ് സൈൻ ഉണ്ടാവും, മൈനസ് a square omega square then psi of omega t. Okay, for simply writing dou psi by dou t is equal to minus a square omega square psi, or ഒന്ന് rewrite ചെയ്യാം. So dou psi by d psi by psi, this psi ഈ സൈഡിലേക്ക് കൊണ്ടുവന്നു, dt ഞാൻ ഈ സൈഡിലേക്ക് കൊണ്ടുവരാണ്, is equal to minus a square omega square dt. ഇനി നമുക്കിതിന് ഇന്റഗ്രേറ്റ് ചെയ്യാം. സോ ഇവിടെ ഇന്റഗ്രേറ്റ് ചെയ്ത ലോഗ് psi എന്ന് വരും, ലോഗ് psi is equal to minus a square omega square t plus ഇന്റഗ്രേഷൻ കോൺസ്റ്റന്റ് ഞാൻ ലോഗിൽ തന്നെ കൊടുത്തു, ലോഗ് c. സോ psi will be equal to, എനിക്ക് ലോഗ് ഒഴിവാക്കണമെങ്കിൽ എക്സ്പോണൻഷ്യൽ എടുക്കേണ്ടി വരും, എക്സ്പോണൻഷ്യൽ മൈനസ് a square omega square t then ഒരു c കൂടി വരും, c into e raised to minus a square omega square t. So what is psi of xt? So psi of xt will be equal to, psi of xt is equal to 1 by root 2 pi integral from minus infinity to infinity psi of omega t e raised to minus I omega x d omega. ഇൻവേഴ്സ് ട്രാൻസ്ഫോം എടുത്തു. psi of omega t ന്ന് psi of xt യിലേക്ക് പോകണമെങ്കിൽ നമ്മൾ ഇൻവേഴ്സ് ട്രാൻസ്ഫോം എടുക്കണം. psi of omega t is equal to 1 by root 2 pi minus infinity to infinity psi of xt e raised to I omega dx. ഇത് Fourier ട്രാൻസ്ഫോം ആണ്. So then psi of xt കാണണമെങ്കിൽ ഇതിന്റെ ഇൻവേഴ്സ് ട്രാൻസ്ഫോം വരും, അപ്പോൾ minus I omega t കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യേണ്ടി വരും. Okay, now this will be equal to 1 by root 2 pi integral from minus infinity to infinity. What is psi of omega t? Psi of omega t is equal to, this is our psi of omega t, c e raised to minus a square omega square t. So this will be equal to c e raised to minus a square omega square t e raised to, now this quantity, minus I omega x d omega. Okay, so this will be equal to 1 by root 2 pi minus infinity to infinity c into omega. So this will be equal to C by A root 2t exponential minus x square by 4a square t as the general solution or particular solution. Psi of xt is equal. So the last step, in the last step we have made appropriate change of variables and parameters. A square is changed to a square t, omega changed to x, t to minus omega, and this yields a particular solution of heat flow partial differential equation. Psi of xt is equal to c by a root 2t exponential minus x square by 4a square t. Convolution theorem. Consider f of x and g of x with Fourier transform f of x and g of x with Fourier transform f of t and g of t. The Fourier transform of f of x is f of t and Fourier transform of g of x is g of t. Then we have f of t is equal to 1 by root 2 pi minus infinity to infinity f of x into e raised to itx dx, and also for g of t is equal to 1 by root 2 pi minus infinity to infinity g of x into e raised to itx dx. Then we define the convolution of f and g over an interval minus infinity to infinity as, so let us define the convolution of f and g over an interval minus infinity to infinity as f star g or f convolution g is equal to 1 by root 2 pi integral from minus infinity to infinity g of y into f of x minus y dy. So this is the definition of convolution of f and g. Okay. Now what is f of x minus y? F of x minus y will be equal to 1 by root 2 pi integral from minus infinity to infinity f of t. So let us take capital F of t into e raised to minus it x minus y dt. So if I find out integral from minus infinity to infinity g of y into f of x minus y dy, that is this quantity, minus infinity to infinity g of y f of x minus y dy, then this will be equal to, so f of x minus y include substitute here, so 1 by root 2 pi, so ഞാൻ ഇവിടെ നിന്നാണ് ചെയ്യുന്നത് മൈനസ് ഇൻഫിനിറ്റി ഇൻ്റഗ്രൽ മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി നൗ ജി ഓഫ് വൈ എഴുതി. സോ 1 by root 2 pi എഫ് ഓഫ് എക്സ് മൈനസ് വൈ എന്ന് വന്നതാണ് 1 by root 2 pi. ഇനി ഈ ടേം ഉണ്ടാവും integral from minus infinity to infinity f of t e raised to minus it x minus y dt then dy. Okay, so once again repeating f. So ഞാൻ ആദ്യം എന്ത് എഴുതി? So f of x minus y ഞാൻ ഇവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. f of x minus y ആണ് 1 by root y minus infinity to infinity f of t raised to minus t x minus y dt. This whole term. Then this g of y, then dy. This integral sign, this integral sign. Okay. Now this can be rewritten as, this is equivalent to 1 by root 2 pi integral from minus infinity to infinity f of t. So this f of t ഞാൻ ആദ്യം എഴുതി, then integral from minus infinity to infinity g of y, so this is g of y, then e raised to I t y, e raised to this it ഉള്ളിലേക്ക് എടുത്താൽ e raised to I t y വരും, then dy dy. So y ന്റെ ടേം മൊത്തം ഒന്നിച്ച് എഴുതി. So it means നമുക്കൊരു ബ്രാക്കറ്റിൽ ഇടാം. Okay, then e raised to minus itx then dt. Okay, just ഒന്ന് rewrite ചെയ്തു. Now the quantity in the bracket can be taken to be, this will be equal to g of t. So already we have defined g of t. G of t is equal to 1 by root 2 pi minus infinity to infinity g of x e raised to I t x dx. Now x ഞാൻ y കൊടുത്തു കഴിഞ്ഞാൽ minus infinity to infinity g of y e raised to I t y dy എന്ന് വരും. അതാണ് ഇവിടെ ഉള്ളത്, g of y e raised to I t y dy. So this can be taken to be g of t. So this integral will be equal to minus infinity to infinity f of t into g of t e raised to minus itx dx. So we have started from the minus infinity to infinity g of y into f of x minus y dy. ആ ടേം നമ്മുടെ കൺവല്യൂഷനിലുള്ളതാണ്, കൺവല്യൂഷൻ ഇന്റഗ്രലുള്ള ടേം ആണ്. So what is our result? So the result is Fourier transform of a Fourier inverse transform of a product of Fourier transform is the convolution of the original function. So let me also write down here, Fourier transform, Fourier inverse transform, Fourier inverse transform of a product of a product of Fourier transform, of a product of Fourier transform is the convolution of the original functions f star g. Now when x is equal to 0, if I substitute x is equal to 0 here, then we have minus infinity to infinity f of t into g of t dt. X 0 ആയി കഴിഞ്ഞാൽ e raised to 0 1 വരും, dt is equal to minus infinity to infinity. Now here x 0 കൊടുത്തു കഴിഞ്ഞാൽ g of y into f of minus y വരും, g of y into f of minus y dy as the special case when x is equal to 0. Parseval's relation. According to Parseval's relation, integral from minus infinity to infinity f of omega into g star omega d omega is equivalent to minus infinity to infinity f of t into g star t dt. And this is also known as Rayleigh theorem. Rayleigh, R-A-Y-L-E-I-G-H. Rayleigh theorem, L-E-I-G-H. So first of all, let us derive this relation. Now using during this derivation, we will use the delta function representation. Delta t minus x is equal to 1 by 2 pi integral from minus infinity to infinity e raised to I omega t minus x d omega. നമ്മൾ ഡിറാക് ഡെൽറ്റ ഫംഗ്ഷൻ ഡെറിവേഷൻ ഫുറിയർ സീരീസിൽ റെപ്രസെന്റ് ചെയ്തപ്പോൾ നമ്മൾ യൂസ് ചെയ്ത ഇക്വേഷൻ ആണ്. Okay, now we have integral from minus infinity to infinity f of t into g star t dt this will be equal to minus infinity to infinity 1 by root 2 pi minus infinity to infinity f of omega e raised to minus I omega t d omega into 1 by root 2 pi minus infinity to infinity g star x e raised to I x t dx into dt. So how I can prove this? First, this step. Okay, so let us prove this step first. Let the Fourier transform of f of t is f of omega. So Fourier transform of f of t is f of omega, and Fourier transform of g of t is represented by g of x. Okay, then f of omega will be equal to 1 by root 2 pi integral from minus infinity to infinity f of t e raised to I omega dt. Also, g of x will be equal to 1 by root 2 pi minus infinity to infinity g of t into e raised to I x t dt. What will be f of t? F of t will be equal to 1 by root 2 pi minus infinity to infinity. This will be inverse transform. F of omega e raised to minus I omega t d omega, and here this g star x will be equal to the g of x ആണ്. So g star x കണ്ടു കഴിഞ്ഞാൽ എന്ത് വരും? G star x will be equal to കോംപ്ലക്സ് കോഞ്ചുഗേറ്റ് എടുക്കണം. Minus infinity to infinity g star t e raised to minus I x t dt. G star t will be equal to an inverse transform. G star t will be equal to 1 by root 2 pi minus infinity to infinity, then g star x e raised to I x t dx. Because g of t ന്റെ ട്രാൻസ്ഫോം എടുത്ത് നമ്മൾ ഫോറിയർ ട്രാൻസ്ഫോം എടുത്ത് g of x ആണ്. ഓക്കെ, ഇവിടെ x ലേക്ക് വരും. സോ ദിസ് വിൽ ബി g star t. ഓക്കെ, ഇനി നമ്മൾ f of t യും g star t യും കൂടി മൾട്ടിപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ you will get this step. നമുക്ക് ഈ സ്റ്റെപ്പ് ഇവിടെ നിന്ന് I am continuing from here. Integral from minus infinity to infinity f of omega 1 by 2 pi integral from minus infinity to infinity. So 1 by root 2 pi ഒരു മൾട്ടിപ്ലൈ ചെയ്തിട്ട് എനിക്ക് 1 by 2 pi കിട്ടിയത് e raised to I x minus omega t dt, then minus infinity to infinity g star x dx d omega. So actually ഞാൻ ഇവിടെ ഫസ്റ്റ് ടീൻ്റെ ഇൻ്റഗ്രേറ്റിംഗ് ഓവർ ടി എന്നുള്ള ടേം ഫസ്റ്റ് എഴുതി. സോ ആക്ച്വലി ദിസ് ടേം ഞാൻ ഫസ്റ്റ് എഴുതിയത് നമ്മളുടെ ഡെൽറ്റ ഫംഗ്ഷൻ ഇക്വേഷൻ യൂസ് ചെയ്യാൻ വേണ്ടിയിട്ട്. ഡെൽറ്റ ടി മൈനസ് എക്സ് ഈക്വൽ ടു 1 by 2 pi minus infinity to infinity e raised to I omega t minus x d omega. ഓക്കെ, സോ എനിക്ക് ആ ടേം ഇവിടെ ക്രിയേറ്റ് ചെയ്യാൻ പറ്റി. സോ ഇൻസ്റ്റെഡ് ഓഫ് ദിസ് ടേം I can write down this is equivalent to this term is equivalent to delta x minus omega. Okay, so this will be equal to minus infinity to infinity f of omega into minus infinity to infinity delta x minus omega g star x dx d omega. Okay, now this will be equal to minus infinity to infinity f of omega. Now delta function, delta x minus omega into g star x endu varum, g of g star omega ennu varum. ഈ x omega, ഈ x omega ഇവിടെ കയറിയിരിക്കും, g star omega d omega. Okay, and that is the proof. We started from minus infinity to infinity f of t g star t dt, and we proved that that is equivalent to minus infinity to infinity f of omega g star omega d omega, and that is our Parseval's relation.